Hello students, welcome to Edura. This is your favorite Professor Arpan again with the new session today. So students, what's there in this session? Yes students, we will be discussing past year MCQs of the topic complex numbers and quadratic equation. So students, this topic is little important because they do ask MCQs from this topic. So without wasting any time, let's start with the first MCQ, and the first MCQ is: if alpha and beta are the roots of the equation x square minus 2x plus 2 equals to 0, then the least value of n for which alpha upon beta whole raised to n is equal to 1 is, let's check our options. Option A, 2. Option B, 5. Option C, 4. And option D, 3. So students, this question was asked in our JEE Mains 2019 exam. And how to solve? Now students, we all know that given alpha and beta are the roots of the quadratic equation. So the equation is x square minus 2x plus 2 equals to 0. So can we write this as x minus 1 whole square plus 1 equals to 0? So students, from this we can say that x minus 1 whole square is equal to minus 1. Now students, when we take square root on both sides, what do we get? So we get x minus 1 is equal to root of minus 1. Now students, tell me one thing, what is root of minus 1? Yes, it is nothing but your imaginary term. So when we write root of minus 1, now students, we have two values, positive and negative. So we will be writing this as plus minus root of minus 1. And we all know that root of minus 1 is I. So x minus 1 is equal to plus minus I. From this, we get two values of x. What are the two values of x? We get x is equal to 1 plus I or 1 minus I. So students, what are the two values of x? X is equal to 1 plus I or 1 minus I. And we know that alpha is equal to 1 plus I and beta is equal to 1 minus I. Now students, what is the question? So according to question, alpha by beta whole raised to n is equal to 1. So we can write this as 1 plus I upon 1 minus I whole raised to n is equal to 1. So students, how do we solve this? Now, is it in your complex form? No. Why? Because there is an imaginary term in the denominator. So if we want to get rid of this imaginary term, this is in division form. So what is the step? Only one step, rationalize the denominator. So when we rationalize the denominator, we will multiply divide with conjugate of denominator. So when we do that, we get 1 plus I into 1 plus I whole upon 1 minus I into 1 plus I whole raised to n, which is equal to 1. Now students, when we do this, let's apply distributive law in the numerator. And if you see the denominator, it is in which form? A plus b into a minus b, which is a square minus b square. So the numerator formed will be 1 plus I square plus 2i whole upon 1 minus I square whole raised to n, which is equal to 1. So from this we get 2i upon 2 whole raised to n, which is equal to 1. So from this we can say that I raised to n is nothing but 1. So students, what is the minimum value of n here? Now the minimum value of n here will become 4. Why? Because we know that I raised to 4 is nothing but 1. Yes students, use the basic. So can we replace 1 with I raised to 4? And when we compare both sides, we get n is equal to 4. So if 4 is the correct answer, what is the correct option? None other than option C. Now students, moving on to the next MCQ, and the next MCQ is sum of the solutions of the equation mod of root x minus 2 plus root x into root x minus 4 plus 2 is equal to 0, where x is greater than 0 is equal to what? Let's check our options first. Option A, 9. Option B, 12. Option C, 4. And option D, 10. So students, again, this was from your JEE Mains 2019 paper. And how to solve this? So we have to reduce the given equation into quadratic equation. So how do we solve? Now, what is the equation, students? It is mod of root x minus 2 plus root x into root x minus 4 plus 2 equals to 0. So students, what should be the next step? So let's multiply this root x inside, and the next step we will write it as mod of root x minus 2 plus x minus 4 root x plus 4 equals to 2. So students, what have we done here? So we have multiplied with root x inside, and along with that we have added 2 on both sides. So that what will happen is, when we add 2 on both sides, x minus 4 root x plus 4, we will write that as root x minus 2 whole square. So the next step of this equation will become mod of root x minus 2 plus root x minus 2 whole square equals to 2. Now students, how to solve this further? So we will write this further as mod of root x minus 2 whole square plus mod of root x minus 2 equals to 0. So students, when we want to solve this further, let us assume mod of root x minus 2 is equal to y. So we can write this equation in a simplified form. So the simplified form of this equation will become y square plus y minus 2 equals to 0. Now students, this is in your quadratic form. So once it is in your quadratic form, it is easy to find factors and roots of this equation. So students, how do we find it? So let's split this as y square plus 2y minus 2 equals to 0. So from this we get two factors. What are the factors, students? Y plus 2 into y minus 1 equals to 0. So from this we have two roots. Y is equal to 1 and y is equal to minus 2. So students, how to solve? So let's consider y is equal to 1 first. Now students, when we consider y is equal to 1, what is y? We assumed y as mod of root x minus 2 is equal to 1. So students, the moment we remove this mod, we get two terms. One is positive, one is negative. So we will write this as root x minus 2 is equal to plus minus 1. So from this we have values of root x as 3 or 1. Now students, if the value of root x is 3 or 1, what will be the value of x? It will be nothing but 9 or 1. So students, if x is 9 or 1, what is the sum of this roots? The sum of this roots is nothing but 9 plus 1, which is 10. So students, if 10 is the answer, what is the correct option? The correct option is none other than option D. And this is how we solve our sum. Now students, moving on to the next MCQ, and the next MCQ is if z is equal to root 3 upon 2 plus I by 2, where we know the value of I is root of minus 1, then 1 plus iz plus z raised to 5 plus I z raised to 8 whole raised to 9 is equal to what? Let's check our options. Option A, 1. Option B, minus 1 plus 2i whole raised to 9. Option C, minus 1, and option D, 0. So students, how do we solve this? Now, what is the question? Z is equal to root 3 by 2 plus I by 2. And we are supposed to find 1 plus iz plus z raised to 5 plus iz raised to 8 whole raised to 9. Now students, this question was asked in our JEE Mains 2019 exam. And how to solve? So students, the best shortcut here is let's use in a polar form. So what is the polar form, students? It is cos theta plus I sin theta. And what is your exponent form? This cos theta plus I sin theta is nothing but e raised to I theta. So you can say either exponent form or you can say Euler's form, whichever name you want to give, you can give. So students, according to our given condition, z is equal to root 3 by 2 plus 1 by 2i can be written as cos pi by 6 plus I sin pi by 6, which is nothing but e raised to I pi by 6. Now students, this is the value of your complex number in Euler's form. Now what is the given condition? So we are supposed to find 1 plus iz plus z raised to 5 plus iz raised to 8 whole raised to 9. So students, we have value of z, substitute, and the moment we substitute, we get 1 plus I into what is z? E raised to I pi by 6. So I into e raised to I pi by 6 plus e raised to 5 pi by 6i plus I into e raised to 8 pi by 6i whole raised to 9. Now students, how do we solve this further? So we will write this step as 1 plus e raised to I pi by 2 into e raised to I pi by 6. How students? We have I, and what is I? I is nothing but a point on y-axis. So we are writing this as e raised to I pi by 2. We all know students that if the real part is 0, that means it is purely imaginary. And if it is purely imaginary, that means it is lying on your y-axis. So we will replace this I as e raised to I pi by 2. So the next step, we will write this as 1 plus e raised to I pi by 2 into e raised to I pi by 6 plus e raised to I 5 pi by 6 plus e raised to I pi by 2 into e raised to 8 pi by 6 I whole raised to 9. So let's use our basics. What basics? Laws of indices. So students, when we use this laws of indices, we know that a raised to m into a raised to n is equal to a raised to m plus n. So with help of our basics, we will write the next step as 1 plus e raised to I 2 pi by 3 plus e raised to I 5 pi by 6 plus e raised to I 11 pi by 6 whole raised to 9. So now convert this Euler's form into your polar form again. So when we convert this into polar form, we get 1 plus, now e raised to I 2 pi by 3 can be written as cos 2 pi by 3 plus I sin 2 pi by 3 plus e raised to I 5 pi by 6 can be written as cos 5 pi by 6 plus I sin 5 pi by 6 plus e raised to I 11 pi by 6 can be written as cos 11 pi by 6 plus I sin 11 pi by 6 whole raised to 9. Now students, we just have to apply the formula of basics with help of our trigo table. So when we apply this formula, we will get the next step as 1 minus 1 by 2 plus I root 3 by 2 minus root 3 by 2 plus 1 by 2 I plus root 3 by 2 minus I by 2 whole raised to 9. So students, how do we solve further? So students, if we rearrange these terms, if we add and subtract terms, we reach to the conclusion that we get 1 by 2 plus I root 3 by 2 whole raised to 9. And students, what is this? This is nothing but cos pi by 3 plus I sin pi by 3 whole raised to 9. Now students, cos pi by 3 plus I sin pi by 3 whole raised to 9 can be written as cos of 3 pi plus I sin of 3 pi. So students, which form? Yes, we have used our De Moivre's theorem. What is your De Moivre's theorem, students? Cos theta plus I sin theta whole raised to n is equal to cos of n theta plus I sin of n theta. So students, with help of De Moivre's theorem, we got the equation cos 3 pi plus I sin 3 pi, and this is nothing but minus 1. So students, minus 1 is the correct answer, and if minus 1 is the correct answer, what is the correct option for that? None other than option C. Now students, moving on to the next MCQ, and the next MCQ is the number of integral values of m for which the equation 1 plus m square whole into x square minus 2 into 1 plus 3m into x plus 1 plus 8m equals to 0 has no real root. What are the options? Option A, it is 3. Option B, infinitely many. Option C, 1. And option D, 2. So students, this was asked in your JEE Mains 2019 paper. And how do we solve? So students, what we have to do is, first we have to convert this equation into quadratic form, and then we have to use the discriminant, that is D. What is D? B square minus 4AC less than 0, because it is already in your complex form. So students, let's convert this into quadratic first. So what is the given equation? So the given equation is 1 plus m square whole into x square minus 2x into 1 plus 3m plus 1 plus 8m equals to 0. Now students, we have already written it in our standard form, ax square plus bx plus c is equal to 0. So from this we have value of a, b and c. What is the value? The value of a is 1 plus m square. The value of b is minus 2 into 1 plus 3m, and the value of c is 1 plus 8m. So students, what is the discriminant? It is b square minus 4ac. So we have a, we have b, we have c. Substitute. So d is equal to what? It is b square, that is minus 2 into 1 plus 3m whole square minus 4 into AC. What is A? 1 plus m square into, what is C? 1 plus 8m. Now students, how to solve further? So we will write minus 2 into 1 plus 3m whole square as 4 into 1 plus 3m whole square. Now students, if you see, there is 4 common with both these terms. So let's take this 4 out. And when we take this 4 out, we get 1 plus 3m whole square minus 1 plus m square into 1 plus 8m. Now students, let's expand this with help of our basic quadratic formula. So when we multiply this, we get 4 into 1 plus 3m whole square is 1 plus 6m plus 9m square minus 1 plus m square into 1 plus 8m. When we multiply using distributive law, we get minus, put a bracket, 1 plus 8m plus m square plus 8m cube. Now students, let's take this minus sign inside, and when we take this minus sign inside, cancel those terms which are getting cancelled, and form a new equation. So the new equation form after cancelling terms are 4 into minus 8m cube plus 8m square minus 2m. So students, from this let's take m common, and along with that let's take 2 common. So when we take m common and along with that when we take 2 common, so students, what do we get? Now students, if you see properly, if we take only 2m common, your m square will be negative. So just to make it simple, let's take minus sign common along with the term 2m. So when we take this minus 2m common, we get minus 8m into 4m square minus 4m plus 1. Now students, if you see properly, 4m square minus 4m plus 1 is in the perfect square form. So we get the next step as minus 8m into 2m minus 1 whole square. Now students, according to the question, there is no solution of this quadratic equation 1. That means d is less than 0. So students, if it is less than 0, that means we will write this as minus 8m into 2m minus 1 whole square is less than 0. So from this we can say that the value of m is greater than 0. So students, there are infinitely many values of m for which there is no solution of the given quadratic equation. So what will be the correct option? The correct option will be none other than option B, which is infinitely many solution. Now students, moving on to the next MCQ, and the next MCQ is all the points in the set S is equal to alpha plus I upon alpha minus I, where alpha belongs to real numbers and I is equal to root of minus 1 lie on, let's check our options. Option A, circle whose radius is root 2. Option B, straight line whose slope is minus 1. Option C, circle whose radius is 1. And option D, straight line whose slope is 1. So students, how do we solve? Now, before solving, this question was asked in our JEE Mains 2019 paper. And students, what is the given condition? So, according to given condition, let x plus iy is equal to alpha plus I upon alpha minus I. Now students, if you see properly, is this in your proper complex form? No. Why? Because there is an imaginary term in your denominator. So what we will do, we will rationalize the denominator to remove this imaginary term. So the moment we rationalize the denominator, we form a new equation, and that new equation will be x plus iy is equal to alpha plus I whole square upon alpha square plus 1. So students, this can be written as alpha square minus 1 plus 2 alpha I whole upon alpha square plus 1. Yes students, we have expanded the numerator, and now after expanding the numerator, let's write in a proper complex form, that is real term plus imaginary term. So we get the next step as alpha square minus 1 upon alpha square plus 1 plus 2 alpha upon alpha square plus 1 into I. Now students, x plus iy is equal to something on your right hand side. So there is a complex number on left side, there is a complex number on right side, there is an equal to sign between them. That means on comparing both sides, that is equating both sides, we get x is equal to alpha square minus 1 upon alpha square plus 1 and y is equal to 2 alpha upon alpha square plus 1. Now students, what is x square plus y square? So x square plus y square, that is squaring and adding both sides. So when we square and add both sides, we get alpha square minus 1 upon alpha square plus 1 whole square plus 2 alpha upon alpha square plus 1 whole square. So students, from this, if you see the base, the denominator is same. So let's write the common denominator, and the numerator, let's expand using basics. So when we expand, we get the numerator as alpha raised to 4 plus 1 minus 2 alpha square plus 4 alpha square whole upon alpha square plus 1 whole square. Now students, if you see your numerator properly, yes, it is in which form? It is in the form of a perfect equation, that is alpha square plus 1 whole square upon alpha square plus 1 whole square, which gets cancelled out, and this is nothing but 1. And students, we get x square plus y square is equal to 1. So students, x square plus y square is equal to 1. This is your equation of a circle which has radius 1. So from this we can say that it is forming a circle whose radius is 1. So students, what will be the correct option? None other than option C. So my dear students, I hope you have enjoyed today's session. I hope it is clear how to solve MCQs of complex numbers and quadratic equations. So students, I hope you enjoyed it. So let's end this session now. And this is your favorite Professor Arpan signing off for the day. Keep watching Algebra. See to it you are strong with your formula. See to it you are practicing regularly. See to it you are strong with your basics.